Hello students. In this class I am going to explain about the your new unit of the sequential circuits. I am going to explain about in this session I am going to explain about the flip-flops. Flip-flops are the combinational circuit of the logic gates. The logic circuit whose outputs at any instant of time are entirely dependent on the input signals present at the time are known as a combinational circuits. Means I'm going to explain about the present situation of that one. I'm going to explain about this one that is called it as a combinational circuits. The logic circuits, it is a sequential circuits. I have told that in it also they have given the sequential circuits. The logic circuits whose outputs at any instant of time are dependent not only on the present inputs but also on past inputs are called sequential circuits. Means that one, the time are dependent not only on the present, the previous or a past times inputs are called as the sequential circuits. In the sequential circuit, output signals are fed back. Feedback means output is given back to the inputs. Thus, output signals can be functions not only on the past input signals but also of the past output signals. It's a block diagram of this flip flop. Can we see that one? This is a flip flops input Fn, F1 like that one. These are the outputs. Yes, this is a feedback for that one. Yes, this is a way the sequential circuits can be explained. In the sequential circuits classified into the two types. The classified into the two types. One is a synchronous. Second one is a asynchronous. One is a synchronous and the one is a unsynchronous. Can we consider it as a synchronous means what? It is a synchronous systems. It has a clock. Clocked signal can be given that one. That is a clock signals can be given. In the change of the synchronous sequential logic systems employ signals that affects the memory elements only at the discrete instance of time. A practical synchronous sequential logic systems used for the fixed amplitude such as voltage levels, the binary signals and synchronization achieved uh, by the timing device called as a master clock generator. This is the sequential circuits they can use for that one. And the asynchronous circuits. Asynchronous is a sequential circuit. It has a latches, right? It has a more faster than the sequential ones, synchronous. Yes, these are the types of the sequential circuits. Next, I am going to explain about the flip-flop latch. Very basic sequential circuit and most widely used in the memory elements is a flip-flop latch. Flip-flop latch means I'm going to draw this circuit. This is a AND gate. This is a yes, this is a R. I'm going to cross connection this one. It is a Q and it is a inverse of that one Q bar. This Q and the Q bar, it is always Q's inverse is a Q bar. These are the two inputs will get that one. This combine interchange that values in the inputs that can be called it as a latches. This point can be called it as a latches. Yes, most probably flip-flops and words we are using. What is the meaning of the flip-flops? A device, it is a device. It is not a particular element or a material. It is not like that. It is a device that exhibits two different stable states, extremely useful as a memory element in a binary systems, is known as a flip-flops. Flip-flops is a digital device whose output remains constant. And one more thing, I am going to use that one. This is a flip-flop. It is always we are giving the expected input, we are getting the expected output. But here we are giving the inputs only, we cannot expect the output value. It is the value comes like that one, we cannot express that one. That is a flip-flops here. Yes, this is the flip-flops. In the flip-flop types, there are the four types of flip-flops. One is a SR flip-flop, JK flip-flop, and T flip-flop, and D flip-flop. These are the four types of the flip-flops we are going to study about in these sessions. And in the SR flip-flop can be used latches, clock, and edge trigger. These are the types of that uh, flip-flops. Yes, we are going to see about this we are going to study about this one. Introduction. The outputs of the digital circuit are dependent entirely on the inputs. Whatever the given inputs, it is the entirely depends on the output. Right? However, there are the requirements of the digital devices or circuit whose output will remain unchanged. Once set, even if there is a change in input level, such a device could be used to store a binary numbers called flip-flop. Flip-flops are used in the construction of registers and counters and in the numerous other applications. Yes, in a sequential logic circuit, flip-flops serve as key memory elements. Key memory elements. Analysis of such circuits are done through truth tables or characteristics equations of flip-flops. The analysis result is normally presented through state table or state transitions diagrams and also through timing diagrams. Yes, can we see this one in the circuits in this one? This is the basic ideal diagram of the feedback line, whatever I have explained that one. One of the easiest way to construct the flip-flop, connect two inverters in the series, known in the figure. This is a figure. Line connecting input devices V inverted A bar, B bar can be used back to the input of the inverter, referred to as the feedback line. This is a feedback line. This is a feedback line. Yes, can we use it? RS flip flops, can we call it? R is first taken and the reset is first and set is later. That's why yes, RS flip flops are can be used. If V1 is a 0 VDC, V3 will be also a 0. V1 is 0 DC volt. V2 is a inverting of 0 is 5 volt. Again inverting of this one is a V3. That wise it's a feedback can be used. In the feedback can be again used to hold a V1 at 0 DC since it's a feedback line. Then bistable circuit this one. Then RS flip flops V1 is 5 volt is here if you are giving. It's a inverting, it is a 0 VDC. This is a V3 is a inverting of that one. Can we use this one as this circuit? A bar. Can we use it like A double bar? A double bar equals to A. That is the A will feedback like that one. It is getting the same answer. Yes. We are getting the same answers. Right? Next. Yes, NOR gate latch can be used that one. The basic flip-flop can be used, improved by the replacing the inverters of the either NAND or NOR gates can be used in this SR flip-flops can be used for that one. Here, I am going to explain about this one in the SR flip-flop. Can we see the truth table of the NOR gates? First, I am going to explain about this is a SR flip-flops. The additional inputs on these gates provide a convenient means for application of input signals to switch the flip-flop from the stable state to the other stable state to the other. RS flip-flops are used. The R is comes first and the reset is comes first and S is comes later. Reset means reset means reset means is 0. Set means it's a 1. It is a low, it is a high. Yes, this is the way to explain about this one. Can we explain about this SR latch or RS latch can be used by the truth table. By the use by the truth table can be used for this one. In the truth table can be taken. SR latch can be used for this one as this circuit can be see that one. Here it is a S and R. This is the output QN. I am going to see this circuit. This is a NOR gate. This is a R, S, V2, V3, Q and Q bar. This is a circuit. Truth table can we take it here as if as if yes are there. Both are 0 if the Qn is high. 0. Qn is 0 it is there. Otherwise ಎಸ್ ಮತ್ತು ಆರ್ ಎರಡು 0 ಇದ್ದಾಗ ಹೈನೂ ಆಗ್ಬೋದಲ್ಲ Q1 ಎರಡು ಸ್ಟೇಟ್ ಫಾಲೋ. State I am going to take that one. It is an equation. S equals to 0, R equals to 0, Qn plus 1 equals to, it is a both I am going to take 0 plus 0. Yes, it is a NOR operation can be bar. This is a equation for the NOR equation. I'm going to see about this one. Same equation. By these equations, here I'm going to take that one. This is the R. Qn plus 1. R is 0, S is 0. R is 0 and S is 0. R is 0 and S is 0. R is comes here. I'm going to, this S is 0 plus Qn bar. That is a reset is Qn bar will come. The whole bar plus 0 plus Qn bar equals to 0 into Qn bar by De Morgan's law. It is a plus is here. Qn bar can be take it. 0 it is a 0 bar is 0 bar into Qn bar. 0 bar is a 1 into Qn bar is a Qn equals to Qn is a answer. That's why there is no change. Qn ಬಂದರೆ ಏನಾಗ್ತದೆ ಯಾವುದೇ ರೀತಿಯಿಂದ ಚೇಂಜ್ ಆಗೋದಿಲ್ಲ ಔಟ್ಪುಟ್ Qn ಇದ್ದಾಗ Qn ಬಂತು ಹೌದಾ ದಟ್ ಈಸ್ there is no change of that one. That's why it is a last state ಏನಾಗುತ್ತೆ ರಿಪೀಟ್ ಆಗುತ್ತೆ ಹೌದಾ ಈಗ Qn ಆಯಿತು ಈಗ ನೆಕ್ಸ್ಟ್ can we take it S equals to 0, R equals to 1. S equals to 0, R equals to 1. Qn plus 1 equals to 1. R is 1. R is 1, third state. R is 1, S equals to 0. R is Qn bar, correct, plus Qn bar 1 bar into Qn bar equals to 0. That is a reset. It is a 1 and the 0, that is a reset. Yes. Next thing, I'm going to take that one. It is a S equals to what it comes? 5. S equals to what it comes like here. It is a this second one. S equals to 1, R equals to 0. Then R equals to 0. Can we take it 0 plus Qn bar whole bar 1 plus 1 into 1 bar into 1 it is correct. It's a 0 bar into Qn bar equals to what it comes. It's a 1 into Qn it comes. Yes, Qn it comes. It is in the can we take it as a Qn? In this state, can we use it for the set? That is a set. 1 will come for that one. That is a set. Last but not the least, it is the can we take it S equals to 1, S equals to 1, R equals to 1. Yes, can we take it 1 Qn bar, Qn plus Qn bar can be used at 1. Can we use it Qn plus 1 equals to Qn plus Qn equals to 1 into 1. It is a 1. Can we use? This is not possible. Not possible equals to Qn is not equals to Qn bar. It will not possible for the practically. Practically it will not comes, just it is theoretically can we use that one. Q equals to Q bar, can we express that one? That is the use of this one. I see one like that one. Yes, this is the latch of the ASR flip-flops. Can we see this one? Any device circuit has any two stable state. It is a toggle switch. This is the SR flip-flops of latch of that one. Can we take? Yes. Uh, Next, can we take the RS flip-flop for the NAND gate? NAND gate can be expressed in this one is the same truth table can be used. S bar and R bar can be take it, but can we use it as a SR? Yes. Can we use it here in the truth table? Can we used S equals to 0? S equals to 0, R equals to 0. Yes. Uh, can we use this one in this NAND gate? Can we use for that one? Output is X can be used that one. I don't know that one. In that session, I'm going to take in this NAND gate of that one, SR flip-flop. S and R can we take? S equals to 0 and R equals to 0. Yes. First condition, Qn plus 1 equals to Q equals to Qn plus 1. Q bar equals to Q1 plus 1 whole bar. Qn plus 1 equals to 0 into, this is a 0 into Qn bar. Yes, 0 bar, it's a whole bar. Can we take it this one? Is it 0 bar equals to 1? That is a 1. I'm going to take the one more example of that one. Qn bar plus 1 bar. What will come that one? 0 into Qn. Correct. 0 into Qn. It is that one. 0 bar plus Qn bar equals to what? It is a 1. Meaning of that indeterminate start of the, this is the last state, it comes like that one in the 0. 0 is a question mark. 0 0. Next one. Next one is S equals to 0, R equals to 1, Qn plus 1 equals to S equals to 0, R equals to 1. In this state, 0 into Qn bar whole bar. Yes, can we use it here in this 1? Answer is 1. Next, Qn plus 1 whole bar equals to 0 into Qn. That is equals to Qn bar. In this way, can we use for this one in the session? That is a 0, S is a 0 and R is 1 can be used at one set. Yes, S is 0 and R is 1 is for the set. Next one is uh, S equals to 1, R equals to 0, S is 1, R equals to 0, S equals to 1 and R equals to 0. This is the equation can be used at Qn plus 1 equals to 1 into Qn bar, multiply here, whole bar, 0 plus Qn equals to Qn, can we use it as a 0? Yes, Qn plus 1 whole bar equals to 0 into Qn bar, that is a 1 can be used as equations, that is a reset, that is a reset. 0 will come for that one, that is a reset. Fourth one is S equals to 0 and R equals to 1. Sorry, S equals to 1 and R equals to 1. Can we use it Qn plus 1 equals to 1 into Qn bar into bar, that is a Qn. Qn plus 1 whole bar equals to 1 into Qn, that is a Qn bar. That is a indeterminate of the form. It is in the no, that is the last state of that one, no change for that one. Q will come for that one, q equals to q, q bar equals to q bar will come for that one, that is a no change equations. And next is this is flip-flops can be used, this one is a circuit for that one, this is the main circuit for that one. It is whatever we have done that one, it is the same like that one, can be used that one. With a clock pulses can be used. Clocked RS flip-flops means it is a synchronous flip-flops with the time can be used that one. The additional of the two AND gates is R and S. Input shown in the figure result. In this figure, result can be used. Flip-flops that can be enabled or disabled. 1. The enable input is low and gate output must be both be low and changes in neither R or S will have any effect on the flip-flop. Output Q. The latch is said to be disabled. Strobe or a clock the flip-flop in order to store the information, set it or reset it at any time and then hold the stored information for any desired period of time. This flip-flop is called a gated clocked RS flip-flop. The time before the enable goes low, Qn, and the time just after enable goes is low. This is the gated of the flip-flop. Enable it is a clock. Enable it is a clock. Enable is always in the high. Can we take the outputs? If it is 0, if it is a always, it is the input and the outputs are in the, there is no change for that one. It is the same for that one. That is the clock pulses can be used that one. Yes, it is known as synchronous circuits. Changed state only in the clock pulses are present. The operation of the basic flip-flop can be modified, providing an additional control input determined when the this clock state. Yes, the clock pulses are in the here the clock pulses. Can we take this one in the clock is 0 can be used at one. Can we use the Qn and the Qn plus 1 can be take. Qn plus 1 can be take. Yes, that is the use of that one in this circuit. Yes, can we see this circuit? Q of t and Q bar of t can be used. Can we use this clock? High and low can be used. Yes, this is the clock. Pulses can be used in these circuits. Can be used in these circuits. Just I am going to take the clock pulses with the SR flip flop for this one can be used for these circuits. Yes, clocks are high. S and the R can be taken. This is the 0 and the 0. 0 and the 0. Clock is in the high. Can we take it as a Qn plus 1? Here the Qn plus 1 it is there. This is the Qn plus 1 can be take it. It is the 1. It is the S equals to 0 and the clock is 1. This clock enters here 1 into Qn bar whole bar. It is equals to 1 bar plus Qn double bar equals to Qn. If the Qn answer will comes for that one, there is no change. In the output Qn it is the Qn will come. Yes, that is the use. Next is a S equals to 0, R equals to 1, S equals to 0, R equals to 1. In this state, Qn plus 1 equals to 1 into Qn bar whole bar. That is equals to Qn bar plus Qn bar whole bar. That is equals to 0 plus 1 it goes to Qn. Qn plus 1 whole bar equals to 0 into Qn whole bar. 1 plus Qn bar equals to 1. Here just neglecting this one. 1 bar is a 0. This is the Qn. This is the Qn bar is 0. This is the exact answer. Can we get it? Yes, that's why it is a 0. That is a 0. That is a reset. Qn bar is 0. It is a reset. Next is the equation for that one. S equals to 1. R equals to 0. S equals to 1 and R equals to 0. Can we use this circuit for that one? Qn plus 1 equals to S equals to 1, R equals to 0. Yes, 0 into Qn bar whole bar equals to 0 bar plus Qn bar equals to 1. This is a one will come for that one. Yes. Next is the inverse of this one can be used. Qn plus 1 whole bar equals to 1 into Qn whole bar. Yes. Qn bar means Qn bar is 0. This is the condition of the Qn equals to 1. It is a set. Last but not the least, Qn plus 1 equals to Qn bar whole bar equals to 1 bar plus Qn bar equals to bar equals to Qn. Qn plus 1 whole bar equals to 1 into Qn bar. That is a Qn bar. That is the undetermined state. This will not comes for that one in the practically. That is the Qn. No change in these circuits can be used. That one. This is the gated of the clocked flip-flops. It is a clock. Yes, this is the way to two different realization for the clocked RS flip-flops. Gated flip-flops. This one is a enable clock. T1, T2, T3, T4, T5. S is a, for example, S is 0011. Yes, S is 00. First clock 11 can be used. That one can be used this 1010 can be this one. Q is whatever the output comes like that one can be write it like that one. This is the waveform of the RS flip flop of the using the NAND gate of the flip flops. Okay, in this session we have explained about the all the RS flip flops can be explained about this. Next session I am going to explain about the D flip flops and the JK flip flops. I am going to explain about that one. And edge triggered flip flop also there for your it is that is also called it as clocked signals can be called it. Clocked signals can be call it for that one. Okay, that is your RS flip flops. Okay, thank you. Please watch our videos regularly.